Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So this is part 3 of our Nokia Lab simulation series. And remember that in part 1 of this series, we discussed some symbol commands, symbol CLI command that you can use to operate and manage Nokia devices. And then in part 2, we discussed how to implement link aggregation on Nokia routing devices. So if you haven't watched the two videos, you can check them out on our channel and have a look. So in this episode, we'll be discussing how to implement multi-area ISIS protocol on Nokia routing devices. So we know ISIS stands for intermediate system to intermediate system. It's a very common dynamic routing protocol that is used on service provider networks. And it's also a link set protocol similar to OSPF. So in this episode, we'll be discussing how to implement the ISIS protocol on Nokia routing devices. And remember that we have discussed how to implement ISIS on Huawei routing devices on our Huawei Lab simulation series. And we have also discussed how to design and implement ISIS protocol for IPERA network. So if you haven't checked the videos on Huawei implementations, you can find them on our channel on Huawei Lab simulation and the IPERA and technology series. So this is the topology that we are using. We have three areas. We have area 10, area 20, and area 30. Area 10 has two routers. We have router 6 and router 2. Area 20 has two routers, router 3 and router 4. And area 30 also has two routers, router 1 and router 5. And we have the IP address planning as shown. The loopback IPs are also indicated. We are using /32 IPs as the loopback IPs. So for the interconnections between different routers, these are the interfaces. Remember, Ethernet 1 will be the C1, Ethernet 2 is C2, and Ethernet 3 is C3. So these are the interconnecting interface between different routers. For the configuration steps, the first step is always to configure ports on all routers. So we need to configure the breakout ports and also to configure LLDP on the interfaces, the link layer discovery protocol, so that we are able to see which device is connected to which device. And once we have finished port configuration, we move to the next stage of this lab demonstration, which will be to configure interfaces between different routers and assign IP address. So we need to configure interfaces, bind the ports, and also configure the system interface on all the routers. Once you have configured the interface, the final step will be to configure ISIS protocol on all routers and activate them on the interfaces. So these are the three steps that we'll be following in this lab. So for the configurations, I've already prepared the configuration, as you can see. These are the configuration that we'll be using. I've mentioned that step 1, we are configuring ports. So we need to configure the breakout ports, the connector, and also enable LLDP on the interfaces. So these are the configurations for router 1. So I will log into the routers and then we can start our lab. So this is router 1. So on router 1, we can configure these ports. So we are configuring port C1. This is Ethernet 1, Ethernet 2, and Ethernet 3. They will be all 100G ports. So I will copy this and then we can configure router 1. Copy. Then I log into the router again and paste. So I can show port. So you see that we have three ports, C1, C2, and C3. They are now up, both admin and link state. If we display show system LLDP neighbor, we don't expect any neighbor because we haven't configured the interconnected routers. So this is the configuration. These are the configuration for router 2. We are also configuring C1, C2, and C3 and configuring LLDP on the ports. So we follow the same procedure as we did on router 1. So I will copy this. router 1. These are the configurations for router 1. Router 2, that is. So I log into router 2 and configure. So I can show ports. So we have 3 ports up, C1, C2, and C3. If I display show system LLDP neighbor, we expect to have one interconnect that is up. So this is connected to R1. So on R1, we can also show system. So we have one neighbor that is up. This is router 2. So we'll move to the next stage. This is configuring router 3. So on router 3, we need to also configure port C1, C2, and C3 and configure LLDP on the ports. So these are the configuration. So this is router 3. I'll paste. You can show port. We expect 3 ports to be up, C1, C2, and C3. Show system LLDP neighbor. So we have 2 interconnecting to R1 and R3, and another one goes to R4. So the next step is now to configure R4. On R4, we only configure one port C1. So we log into R4 and configure it. Port C1, enable LLDP, exit, show system LLDP neighbor. So we have interconnection to R3. So now on R3, we expect to have LLDP neighbor to 3 devices. So we have connection to R1, R2, and R4. Then we can configure R5. So R5, we are also just configuring R1. Log into R5, configure it, exit, show system LLDP neighbor. We have one neighbor to R1, and finally we need to configure R6. So on R6, we configure port C1, enable LLDP on it. So I can display show system LLDP neighbor. We have a neighbor to R2, and this is the remote port. So this is the power of LLDP. You can easily detect which devices are connected to the local device. And we use the command show system LLDP neighbor to see the information. So we have finished configuring the physical port. Now we need to move to the next stage of our lab and configure interfaces on all routers and assign IP addresses. So the interfaces that we need to configure interface interconnecting different routers and assign IP address, and also assign IP address to the system interface. So the system interface is like the loopback 0 interface, and it's used for the management, and even we'll use it when we are generating the system ID for SIS. We'll use it as the router ID for other protocols also. So if we show router interface, this is the command that we can use to show the interfaces configured on the router. You can see that we have the system interface, but we don't have an IP address assigned. So that's why we need to configure IP address on this system interface. So on R1, we are creating 3 interfaces. We have interface to R2, assigning IP address as per the planning, and then we give it a description, and then we bind the port. So this is how you bind the port, and then you enter the port number, and we unshut the interface. And then we create another interface to R3, do the same, assign IP address /31, description, port, and unshut the port, and shut the interface. So for interface system, we just need to assign the IP address, and this is the IP address for loopback 0 that we have designed on our lab. So I will configure R1. So on R1, we need to configure the interfaces, exit, and then paste. So I can run the command show, or we can do info first. Info gives you the detailed configuration under this hierarchy. So you can use it more often to verify that your configurations are okay. So I can show router interface. When I run the show router interface, you can clearly see that it's giving us the interface name, the IP address, the admin states, the operational status. You can see that the version 4 it's up, the mode it's a network, and then the port that we have bind on that interface. So these are the details that you get. You can see that our system interface is now up and it's operational on version 4. So we can configure router 2. So for R2, we also need to create 3 interfaces. We create interface to R1, to R3, and R6, and then assign IP addresses accordingly, and also create configure IP address on the interface system. So I will copy this, log into R2 again, exit, and configure. So I can do info. We see the configurations under configure router interfaces, and then I can show router interface. So we have the interface name, the admin status, operational states, the mode, and the port that is bind to that interface. So we can do configurations on R3. On R3, we need to create 3 interfaces, R1, R2, and R4, and also assign IP address of 3.3.3.3 to our system interface. So we can do that right away. On R3, I paste, run info. These are the configurations that we are using on R3. Show router interface. We have 3 interfaces to R1, to R2, to R4, and the system interface. So we can finish by configuring our edge routers. R4, we just create 1 interface and assign IP address to the system interface. So on R4, we run these commands. Can do info just to verify the configurations again. Interface to R3, the IP address is there, mask/31, description, the port that we are using, and then we are inserting the port, and then we assign IP address to the system interface. So I can show router interface. These are 2 interfaces to R3 and system interface. So we can configure R5. So for R5, we just create 1 interface and configure IP address on the system interface. Again, do info, show router interface to verify that we have 2 interfaces, the operational and admin state is up. And finally, we configure R6. So on R6, configure info, we have the interfaces, and then show router interface. We have 2 interfaces to R2 and the system interface. So we have finished configuring the interface. Show router interface on R1 again. We have these interfaces. We can ping interconnecting peer interface .40. We are able to ping. We can ping just to verify that our configurations are okay. 30.30.30.31. We are able to ping the far end device. Again, show router interface. We can ping to R5 50.50.50.51. We are able to ping. We can verify on R3, show router interface. We can ping, let's try the two remaining interface 20.20.20.20, we are able to ping, and then 10.10, 10.10.10.11, we are able to ping. So this one confirm that we have connectivity between the different routers. So we have configured the interfaces, we have configured the ports. The final stage is now to configure ISIS. So these are the ISIS configuration. We are configuring ISIS process 30 on router 1, and then we are configuring the system interface at the router ID. The area ID is configured as 49.0030, and then we are enabling ISIS on the interfaces. So this is where we are enabling ISIS on the interface. You have to define these interfaces under the ISIS configuration. And then you can specify the interface type to either point-to-point or broadcast. And then you can also configure the metrics. So if you don't want to use the reference metric, you can manually configure the metric on the interfaces. And you can also the capabilities. So remember, we have level 1, level 1, 2, and level 2. So you can specify the level that you want your interface to be in. So you can see that these one, they are defined as level 2, and the metric is configured as 100. So these are the ISIS configuration that we need to apply on R1. So I will copy this, log into R1, exit again, and configure. So you need to be in the right configuration hierarchy for you to apply this. Seems there is a problem. Let me see. Where is it? So we have interface to R2 level capability. So let's just configure router ISIS 30 and do info. Interface system, seems there is a problem somewhere. To R5, let me copy this one again. And see where the problem is. I'll paste configure router ISIS 30 info. If I run interface, to R5, on R1 we don't have interface to R5. Let me check the topology again. On R1 we have interface to, let me show the router interface. Show router interface. So we have to R1 to R2 and R4. So we need to correct R1, R2, and R4. On R1, let's verify again from the topology. So we have R1, we need to add interface to R2, R3, and R1. So what we need to do is R1, R2, and R3. So this should be okay. Let's configure it. We can start by configuring the first interface. Let's see, paste. That is okay. We can do the other interfaces. Paste. Does to R3 does not exist. Show router interface again. We have to R1, R2, and R4. So this one should be R4. That is a mistake. So I can configure the two interfaces. Configure router ISIS 30. Paste info so that we see the configurations. So we have interface to R1, interface to R2, interface to R4, and we also need to the system interface. Just verify that we have, yes, we have the interface system. So these are the configuration that we need to apply on R1. We can check on R2 and just verify that we have the right interface. So on R2, we need to have, on R2 we have interface to R6, R3, and R1. R6, R3, and R1. So I will configure the configurations on R6. This is R2. Oh, we are on the wrong router. That is why we are reporting errors. This is the problem. So what I need to do is I can just configure router. No ISIS 30, that is it. So we can redo the configurations on R1. I just need to change, sorry for that. We need to, on R1, so on R1 we have R3 and R5. We can verify that on R1. Show router interface. So the configurations were okay, but we were on the wrong router, so we need to configure R1 to be with R2, R3, and R5. Sorry again for that. R2, R3, and R5. Yeah, that is correct. So we were applying these configurations on the wrong router, and that's why it was reporting an error. So on R1, I will exit and apply the configuration. Configure router ISIS 30 info. So these are the configuration, the router ID, the area ID, the interfaces, the metric. So we can configure R2. On R2, we are enabling on interface R6, R3, and R1. So I will copy this and apply it on R2. So I log into R2, I will exit, go to the right configuration hierarchy and apply. Configure router ISIS. This was which process? Just to verify, it's ISIS process 10 info. We have the configurations. Then we'll do the same for R3. We need to apply to interface R1. We apply to interface R1, R2, and R4. So we can log into R3, exit, go to the right configuration hierarchy and apply the configuration. Then on R4, we also need to configure ISIS and enable it on the system interface and interface to R3. So we log into R4, exit, and apply the configurations first. And then on R5, we do the same. We configure ISIS process 30 and enable it on the interfaces. R5, exit, and apply. Then finally on R6, we apply to interface R2 and to system interface and configure the metrics. So on R6, we'll exit from this hierarchy and go to the right hierarchy. So now we have finished configuring our SIS protocol. We can verify the status. So the command we use is show router ISIS. If you know the process, you can just type process 30 question mark. Remember, we have a question mark for help, and then you can do adjacency. So on R1, you can see that we have three adjacencies. We have adjacency to R2, R3, and R5. We can show router, ISIS, process 30, adjacent the detail. This one gives you more details. You can see that it shows you the uptime for these ISIS. So if there is any issue on the protocol level, you can be able to tell when there is a flap using this command. From the uptime, you can see how long it has been up. And then we have the system ID generated from loopback 0. Then we have the hold time, the topology, and many other details that you can see when you use the detail command. So you can also use show router ISIS, or if you have multiple ISIS process, you can use the all adjacency. So it will give you the ISIS adjacency in different ISIS processes. I want to see the interface, or I just focus on 30 and then interface. So you have ISIS interfaces. These are the three interfaces, the four interface system to R2 to R3 and to R5. And you can see the levels, level 1, 2, level 2, level 2, level 1, 2. So we can also show router ISIS database. We need to specify the process, show router ISIS all database to see the LSDB. So you can see the LSDBs in different, the LSPs in different levels. So we have level 1 and level 2. So you can see the detailed information, the LSP ID, sequence, checksum, lifetime, and the attributes. So this one verify that our ISIS configuration on R1 are okay. On R2 we can do the same. Show router ISIS all adjacency. We have adjacency to R1, R3, and R6. Show router ISIS all interface. So we have process 10 and we have these interfaces in ISIS process 10. You can show router ISIS all adjacency detail. And you will get many more details, the uptime, the max hold, the circuit type, and many other information that you can obtain when you use the detail command. So on R3, we can show router ISIS all adjacency to verify that we have adjacencies up. The state is up. We have adjacency to R1, R2, and R4. On R4, we can also show router ISIS all adjacency. We have one adjacency in ISIS process 20. 5 show router ISIS all adjacency. We have one adjacency to R1. We can see the uptime with the detail command. Show router ISIS all adjacency detail. So you have the detail information. Finally, on R6, we can show router ISIS all adjacency. We have one adjacency. We can show the route, show router ISIS route. ISIS show router ISIS. If you don't know the process that is configured, you can use the tab 10 routes. So we have learned these routes from ISIS, and you can see that we should be able to ping the loopbacks of different routers. On R1, we can also verify show router ISIS all routes. So we have learned routes from different routers. 1, 2, 3, 4, 5, and 6. So we should be able to ping the different routers. On R3, finally, we can also show router ISIS all routes. We can check the routes also by show router routing table, route table. That is, you can see that we have ISIS routes coming in, protocol ISIS. So this one verify that our ISIS configurations are okay, and all the other configuration, the interface configuration, port configurations are also okay. So this is how simple it is to implement multi-area ISIS protocol on Nokia devices. I hope you have enjoyed the session. If you've enjoyed, please hit that like button. And if you have any comment, feel free to comment in our comment section. And please remember to subscribe to our channel for more upcoming videos. Thank you.